Hello and welcome back to our third and final video on compound interest and associated formulas. In this video, we are going to examine the effective rate. And the effective rate, which is normally denoted as R with the subscript of EFF. This is the simple interest rate needed to yield the same amount of money at the end of 1 year as a compounding interest rate would yield. This is sometimes referred to as the effective annual yield. R with the subscript of ST is the stated rate, or sometimes called the nominal rate. And what this essentially is this is normally what is told to you when you are working with compound interest calculations. They normally give you this stated rate or this nominal rate. Sometimes people may even refer to this as the just the annual yield, or the annual percentage yield, or the annual percentage rate. Now, the formula for effective rate appears like this. You have R subscripted with EFF, and this is equal to the quantity 1 plus the stated rate divided by n. That whole sum is raised to the n power, and then you subtract 1 from that result. And this is used to compare different compounding interest rates to see which one is offering the best deal. If you are borrowing money, you want the lowest effective rate. If you are loaning money, then you want the highest effective rate. And the reason for this is because, remember, interest is basically a fee that you would pay in order to borrow someone else's money. They are loaning you money, and they're taking on a certain amount of risk that you will pay it back or not. So they're charging you a little bit to borrow this money because you don't have it available. So this is kind of what interest is. And so if you're borrowing this money, you don't want to pay more back on the same amount of money that you're borrowing. And again, if you're loaning money, then you want to receive the highest amount back. So this is what the effective rate does, is that it kind of quote unquote levels the playing field so that you can compare compound interest rates to see which one is offering you the best deal. Now, the derivation of this formula is that you take the quantity P times quantity 1 plus R over N raised to the NT power minus P. Now, remember, that is the amount of interest that you would earn from compounding interest. And you set that equal to P times the effective rate times T. That's the simple interest rate formula. So when you set those two equal to each other, then you can go through and say that by definition, the time is just 1 year. So T is 1. So that's how to get rid of the T variable. You substitute 1 into it. And then we're going to divide all of the terms by P, the principal. And when we divide that out, we get our formula for effective rate. Now let's see an example. Suppose that Nations Bank is lending money at 13.2% interest compounded annually. The rate for First Union is 12.6% compounded monthly, and the rate at BB&T is 12.7% compounded quarterly. If you need to borrow money, at which bank will you pay the least interest? So because all of these banks are offering different interest rates, we need to level the playing field for comparison purposes. So we're going to compute the effective rate for each one of these situations. Now, Nations Bank, when we put in the information for that, we have 1 plus 0.132 divided by 1, and that's all raised to the first power, and then minus 1, and we end up with 13.2%. So Nations Bank, the simple interest rate needed to match the compounding interest rate is 13.2. For First Union, we plug in their values, where we have 1 plus 0.126 divided by 12. And then we're going to raise that sum to the 12th power, and then we'll subtract 1 from that. And we end up with about 13.4% simple interest rate, or effective rate. And at BB&T, they're offering a 12.7% compounded quarterly. Plugging in those numbers, we have 1 plus 0.127 divided by 4, and we raise that to the 4th power, and then we subtract 1 from that result, and we get about 13.3%. Now, because we're borrowing money we're going to want the effective rate that's the lowest among these values. And that happens to occur at Nations Bank at 13.2%. Now, you might come across some alternate notations as you do searches for these formulas in other resources. Now, if you see the little I, this is normally R over N, and it's common to replace this ratio with the letter I instead of scribing with fractions. One thing that happens in finance fields is that they try to keep their formulas looking very, very simple. So this little I is often called the interest rate per period. And it does make the formulas a little bit easier to remember. There's not so much fractions involved and things of that nature. So if you do see a little I, remember this is often replacing, I should say, R over N to make the formula a little bit easier to remember. Now, capital N is sometimes used to represent the number of compounding periods, and that's done by taking the number of compounding periods per year and multiplying by the number of years. So sometimes you might see a formula with a capital N in there instead of N times T, and again, it's just representing the number of compounding periods as done in the derivation in the first video. So here's a summary of the formulas that were given in this little series of videos. We have the future value for compound interest, where we have A is equal to P times the quantity 1 plus I raised to the NT power. Remember, I is R over N. The present value, we solve this for P, and we have A divided by 1 plus I quantity raised to the NT power. We have the future value of continuously compounding interest. A is equal to P times E. Remember, E is that 2.71828 number, and that number is raised to the RT power. So you take 2.71828, raise it to the R times T power, and then you multiply that result by P, and you have the future value for continuously compounding interest. In present value formula for continuously compounding interest, you have P is equal to A divided by E to the RT power. For the effective rate with discrete compounding, we have the quantity 1 plus I raised to the N power minus 1. Remember, this effective rate is done over 1 year, so T is equal to 1 in this situation. If you do come across a situation where you are using the effective rate for continuously compounding, then we can use the approximation that E to the R is approximately equal to 1 plus R over N to the N power. And you can take that E to the R minus 1, and that'll give you the effective rate for continuously compounding interest. And this is the end of our video series for compound interest. I thank you for your time and attention.